This example comes from section 4.3, trigonometric ratios. So in this example, we're told that the point A, and we're given some coordinates, -4/5, 3/5, lies at the intersection of the unit circle and the terminal arm of an angle theta in standard position. We're asked to draw a diagram, which I'd recommend doing even if you weren't asked to, and then told to determine the values of all 6 trig ratios for theta. So our diagram is basically just a picture of a unit circle. Doesn't need to be too perfect, and that definitely is not perfect. A coordinate like A, which has a negative x value and a positive y value, must be somewhere over here in quadrant 2. So I'll call this point A, -4/5, 3/5. Now, we're asked to find the 6 trig ratios, so let's write down what the 6 trig ratios are. Sine theta, cos theta, tan theta, cosecant, secant, and finally cotangent. If we can find all 6 of those, we'll be done. Now the good news about these coordinates being on the unit circle is that the first one is cosine theta, -4/5. The second coordinate is sine theta, 3/5. So hopefully we've learned that in section 4.2 about the unit circle. The reciprocals of those are relatively easy as well, if we know which one is which, and we have a formula sheet that can tell us if we forget, but cosecant is just the answer for sine flipped upside down. So the reciprocal of 3/5 is 5/3, and secant is similar. You take the answer for cosine and turn it upside down. Tangent is not directly read off the unit circle, but it is equal to sine over cos, which again is on the formula sheet. So if you take these two and you say 3/5 and divide it by -4/5, a little bit of work with fractions, 3/5 times -5/4 equals -3/4. So the answer for tan is -3/4, and cotangent is the reciprocal of that, so it's -4/3. So you have all 6 values of the trig ratios and a little diagram that goes with it. I suppose if we're going to draw technically theta in standard position, we should complete the drawing, something like that, and you're done.